Okay, first of all, work. Work is force times distance. How is force related to pressure? With area. So pressure is force per area. Don't make me get your cup out. Start calling on you. Therefore, the force is equal to what? F is equal to pressure times area. Beautiful. So let's substitute that back in for our force. Boom, right there. So then work would be pressure times area times distance. What happens when you multiply area times distance? What do you get? Volume. That's right. If you multiply an area times a distance, you get a volume. So work is equal to pressure times volume in the most simple terms. Okay, so now let's look at that water tank idea. And so we'll just have a fluid in a pipe up here. And this fluid, this pipe right here, is going to go through a height change. Whee! Down here. And pretend like I'm a very good artist and I can draw this so that it's all beautiful and consistent. But I'm not purposely trying to change the cross-sectional area here. Just not pretty drawing. Okay, so let's mark the midpoint of our pipe, because on average, that's the average position of a water molecule or a liquid fluid molecule. Some of them are down here, some of them are up here, but on average the height is at the midpoint. And here, again, the height, the average height would be at the midpoint of the pipe. Let's call this height y1 and this height y2. And if this is open to the atmosphere, then there would be a pressure acting on this open end. And I'm going to call it P1. Or maybe it's not open to the atmosphere and I have a pump, okay, a water pump. If you have an aquarium, there's a water pump that pulls the water up through the filter. Or if you have an air pump for your aquarium, it's pumping air and causing the bubbles in the water. And if you have a restroom in your house, like on the bottom level, you may notice that when you flush, you hear kind of a different noise there than you may in other parts of the house. And it may be because that restroom is below the sewage line. And so we have to pump that fluid up to that higher point, because where does everything want to run? Downhill. Water always goes downhill, even unclean water. So you might hear that pump. But anyway, so we can apply a pressure via a pump and cause fluids to move. But if it's open to the atmosphere, that's the best way to think about it for right now. And then down here, it's open to the atmosphere too, but it pushes back on it. So I'm going to call that one P2. And again, my pipe is full of a non-compressible fluid, and that non-compressible fluid has a speed of V1 up here and a speed of V2 down here. Now the force due to the pressure is not conservative. It's non-conservative. It's not the gravitational force. It's not a honorary spring force that we pretend is conservative for the sake of our class, and it's not an electric force. The pressure force is not one of our conservative forces. So the work done by the pressure, the difference in pressure at the top and the bottom, is non-conservative. Do you remember non-conservative work? The work done by a non-conservative force. Work NC was equal to delta K plus delta U. Okay?